How did we go from a bunch of rocks to the vast expanse of life we see on Earth today? Well, the story's long, but I'm gonna make it simple. If you watch this video to the end, I promise you will have a firm understanding of how life began on Earth, how it evolved, and what this tells us about ourselves, aliens, and the entire universe. To investigate this question of how life arose from rocks, something called a chemosynthetic reaction must occur. A chemosynthetic reaction synthesizes organic molecules from inorganic molecules. Great, but that sounds impossible. Well, actually we know it's possible, we know that it occurs, and we know exactly where it occurs. But for this we must look deep underwater, almost 4 billion years ago, in the dark neighborhood of hydrothermal vents. Hydrothermal vents are cracks in the Earth's surface that release gases from the mantle and core. Some of these gases are hydrogen, the first element on the periodic table and the most abundant element in the universe, carbon, and oxygen. The origins of life may have started with these. Let's look to an equation. In this equation, carbon dioxide is combined with hydrosulfide to produce organic molecules. The organic molecules are represented by CH2O, a simple carbohydrate. This is the chemical reaction that occurs at hydrothermal vents that creates organic molecules. This shows that the origin of life on Earth is not a miraculous spark like in Frankenstein. It is created by a unique combination of high temperatures, extreme pressures, and the chemical energy of hydrothermal vents. But we look a lot different than CH2O. Isn't that a problem? Well, this is where evolution comes into play. The continuous evolution and dynamic dance of these molecules over almost 4 billion years created the vast array of life we have on Earth. Let's investigate one part of this long chain of evolution. So with chemosynthesis, we have organic molecules, essentially food. Over time, this organic molecule that was once an output of the reaction becomes the input. Essentially, the original reaction we talked about reverses. Now we have an organic molecule being used in a process to create carbon dioxide and hydrogen. Pay attention because this is the important part here. As the hydrogen is created in this process, it leaves the reaction and passes through a membrane. This creates an electrical charge. This charge, this electricity, is the sustaining force for life. Let's watch a biochemist named Nick Lane explain this another time, and maybe we'll understand it a little bit better.
This is another problem with biochemistry. All these difficult names, but actually all it's doing is passing on two hydrogen atoms. Where's it passing them to? It's passing them into the membranes. 2H are being split up. I'll show you what happens in a moment. But they're eventually reacting with oxygen. And that's what's generating all our energy in the form of ATP. This reaction between hydrogen and oxygen, you can think of it as rocket fuel, really. This is what's powering us. This is what's making us alive. In this slide is what makes us different to a corpse.
Essentially, what we have done in this video is uncover the equation that creates life and the equation that powers life. This is, at its most basic, how we went from rocks to everything we see around us. Lots of information was left out in this video, and if you want to learn more, I'll leave the link to a great video in the description, but I think that's about all the biochemistry I can do for one day. Leave in the comments below if you think alien life must have been created in a similar process, or if you think it could have been created in a different way. Is this the chemical reaction that underpins all life in the universe? I hope you all enjoyed the video. If you did, like and subscribe, and I hope to see you next time.